Over the past few months, I've been trying to beat as many Mario Party DS minigames as I can using only Python and showing off different machine learning techniques along the way. Originally, I was going to wait until I completed all 32 4-player minigames before making this video, but I realized that would have been a very long video, and I'm not sure if this is something people are interested in watching. So for today's video, I'm going to go over 10 different minigames and how I wrote code to beat them. If you guys enjoyed this video and want to see more minigames being defeated, make sure to give this video a thumbs up. Also, don't forget to subscribe and leave a comment down below letting me know which minigame is your favorite and which minigame you guys would like to see included in part 2. Anyways, let's get started. We're going to start with the very first minigame on the list, Goomba Wrangler. In this game, you're going to want to capture as many Goombas as you can to accumulate points. You capture Goombas by drawing a circle around them, golden Goombas give you more points, and Bob-ombs make you lose points. The first thing we need to do is actually locate the position of the Goombas. To do this, we can take the color of the Goomba and create a mask. No, not that kind of mask, an image mask. Image masks are super helpful because they allow us to take an existing image and extract only the information that we care about. Let's say I only want to isolate the pixels whose colors closely match that of a Goomba. All I have to do is create a mask that searches for this Goomba's brown color. If I want to broaden the search up a little bit, I can create an upper and lower color bound and collect all of the colors that fall within this range. I can go ahead and create a second mask to find all of the golden Goombas. And just like that, we've made good progress. With these new masks, we can start looking for contours. We can think of contours as the perimeter of an object. Computers are really good at finding contours for you, especially if they are easily identifiable, which in our case they are. When a contour is found, we're given its position, and that's how we're going to keep track of our Goombas. The final thing we have to do is actually capture the Goombas. If you were playing this game yourself, what you would do is create a circle around the region that you want to capture. Everything within this region will be claimed, including Bob-ombs. When I first started this challenge, I actually wrote some code that takes the position of a Goomba and creates a circle around it with some predefined radius. But then I realized that I didn't have to do that. All I needed to do was create an enclosed area around the Goomba. It didn't have to be a circle. So instead, I opted to create squares instead. Squares are much easier and more efficient to create than circles. And that was it. If I wanted to be more careful, I could have created a third mask to find the positions of the Bob-ombs and then make sure that the squares that I was creating were safe. This isn't leak code, and I'm not trying to find the most optimal solution, so I'm happy with the way this turned out. Anyway, let's move on to the next one. For this game, you have to launch yourself off this railing by quickly swiping your stylus on the touchpad. The person that travels the farthest distance wins. This one is super straightforward, and I'm not going to spend a lot of time talking about it. Basically, all I had to do was write some code that takes your mouse from the bottom of the screen to the top. And that's it. I'm not gonna lie, this one took a hot minute to beat, but I'm really proud of the solution. You're essentially playing 4-card Monty. You play 3 rounds, and the person with the most correct guesses wins. I thought about using techniques such as template matching or motion tracking to try to keep track of my card as it gets swapped, but I wasn't able to create something consistent. The cards moved a bit too fast for the program that I wrote, and there were instances in which cards overlapped, which confused my code. The idea that I came up with started with this technique where instead of tracking the whole card, I only paid attention to the white border at the bottom. We start by placing a tracker on the 4 locations where each card should be at. If the tracker picks up a white color, then we know a card is there. If not, then we know the card is missing or being moved. This is actually the way my card knows which card to keep track of at the beginning of the game. I want to keep track of which cards are being moved. To do this, I kept track until 2 trackers did not return white. When this happened, we could assume that those 2 cards were being swapped. Once this move was detected, I would stop tracking until all of the cards were at rest before tracking the cards again. During this process, I discovered something that would make things even easier. I realized that with 4 cards, there are only 6 possible swaps that can be made. A detail to notice is that when the cards are swapped, they do so in this looping pattern. And that's when I realized every single swap has a unique loop. This changed everything. This meant that I didn't have to keep track of rest values or anything like that, except for the beginning, of course. All I had to do was keep track of this particular part of the screen. When 2 cards are being swapped, one of the cards is going to cross this white line. I can then get the location of where the card was located when it crossed the line and reference it to a hash map that stores the location of the card to the swap pair. For example, if we notice that a card crossed the line at this position, then we know that this particular spot corresponds with this loop, which means that these 2 cards are being swapped. We can then swap those 2 indices in my array, and we now have a successfully swapped array. There's a bit more code that went into this, such as accounting for the fact that at the beginning of each round, when the card is being slid into position, it actually crosses our boundary, and we don't want to count that as a swap. And then of course there was some code that adds a bit of a delay to take into account the time between rounds, but that stuff is boring. I was just really proud of this swap logic and I wanted to prioritize that. Anyways, that's Dress for Success. On to the next one. Alright, let's take a break and let's do something a little bit easier. For this game, all you have to do is try to get as close to the bottom of the chalkboard without crashing. The person closest to the bottom wins. This one is actually pretty easy, especially given the fact that there is a bright red line that indicates the bottom of the board. I simply placed a visual cue where my code anticipated this red line to cross through. Once it crossed, I clicked A, and that was it. Not every minigame is going to be super complicated. I wanted to showcase this game because it uses 2 different techniques that we have already talked about, image masking and visual cues. In this game, you're swinging across a garage and you have to time your jump so that you land on a piece of trash. The catch is, the trash differs in size, ranging from a tiny paper cup to a large toolbox. To begin, I created an image mask to find the location of the landing zones since most of them have this grayish color. I made sure to create a second mask to track this red toolbox. At the beginning of the game, you're given the option to select any rope you'd like. The choice doesn't matter as it's RNG, plus because we're doing this via code, we should be able to win no matter which selection we make. That is to say, we're going to stick with the left-hand rope for every attempt. Anyways, with these image masks, I created a visual cue that will let me know when to let go of the rope. It took a bit of trial and error, but in the end we were able to land on the tiny cup as well as the large toolbox using the same timing. And that's it for that one. Okay, this one is really fun and straightforward. All you have to do is hit the button that corresponds with the icon on your screen. Be the first one to make it to the end and you win. In an attempt to showcase different techniques, for this one I used the process known as Optical Character Recognition, or OCR. OCR is the process that takes text from an image or screen and transforms it into a string that a computer can understand. Now, before anyone says anything, yes, there are easier ways to go about this, but like I said, I wanted to showcase different techniques, and this one seemed fun. With this information in mind, I'm pretty sure you can tell where I'm going with this one. What I did was isolate this part of the screen that contains the button I'm supposed to press. I then ran this image through PyTesseract and then let me know which letter was on screen. Simple as that. From here, I just wrote some code to hit the button that corresponds with the letter on screen, and that was it. Okay, so I don't usually like showing my code because I don't think it's very interesting. I think the concept and ideas are more exciting and more appealing to watch. But I'll make an exception this one time. Here is my code for a Cheep chance. Yep, that's it. Not a joke. This game is completely luck-based and there is no skill whatsoever. In this game, you pick a rope and you hope there's a fish at the end of the line. If you get a fish, you win. If not, you lose. That's it. The top screen and the bottom of the screen do not match up, so it's literally just RNG. I was going to write some code to randomly pick a rope, but I didn't have to do that either. If you don't make a selection, the game randomly chooses a line for you. With that being said, I did have to play this game 5 times in order to win, but that's it in terms of code. While we're on the topic of easy games to program, next up we have Get the Lead Out. In this one, all you have to do is mash the A button as fast as you can. As you might expect, the code for that is pretty easy. Here it is. We also have Cherry Go Round, where you are tasked in launching a cherry as far as you can. To do this, you simply move your stylus in a circle as fast as you can. For this one, I actually used the square making code from Goomba Wrangler, and I just modified the parameters a little bit. Doing so gives us this perfect launch every time. Okay, it's time to get back to some actual thinking. Here we have Boogie Beam. In this game, all you have to do is hit the button that corresponds with the correct action. To be more specific, if you are in the spotlight, you hit the orange button. If someone else is in the spotlight, you hit the purple button. To beat this game, I used a technique very similar to that of Dress for Success. Funnily enough, I actually wrote the code to beat this game first. Anyways, what I did was keep track of this particular spot in front of every player. If the spotlight is on, then you would expect the color to be a bit brighter, and in fact, that's exactly what happens. So what I did was keep track of all 4 positions in the form of an array, with the first value representing us. When a light turns on, the index that corresponds with that player will turn into a 1, otherwise it will stay at 0. Since there will always be at least one light that turns on each round, what we can do is wait for the sum of the values in the array to no longer equal 0. If the sum is not 0, then we know at least one light is on. When this happens, we can then simply take a look at the first value in the array and see if it's a 1 or a 0. If it's a 1, then we hit orange. If not, we hit 0. And that's it. Pretty simple, but a lot of fun. The last game I want to showcase is Star Catchers. Technically, this isn't classified as a 4-player minigame and is instead classified as a duel, but I wanted to showcase it anyways. For this one, what you have to do is select the stars as they appear in the night sky. If the star is white, they are unclaimed and you must click them in order to claim them. The person with the most stars at the end of the game wins. We're going to do something similar to Goomba Wrangler. I created a white mask to better isolate the unclaimed stars. From here, just like we did with the Goombas, we can create contours around the stars that we can then detect and find their positions. It's a pretty simple game, but I think it's very aesthetically pleasing, and I thought it was a nice way to wrap up this video. As I mentioned before, if you guys would like to see a part 2, please feel free to let me know. I started working on some more minigames that I was originally going to include in this video, but I felt like this video was going to be long enough as is. So yeah, remember to like this video if you enjoyed it, subscribe if you haven't already, follow me on my other platforms, and leave a comment down below if you want a part 2. Other than that, thank you guys so much for watching, and I will see you all next time. Peace out, everybody.